one other question that just came up was, what about the OSHA training? So I'll give you a little bit of background on that. This course, Recycling Technology, was sort of born out of a Department of Labor grant. So the Obama administration several years ago set aside $2 billion for two-year education. And so, Missoula College is a two-year institution, and one of the sectors that I identified as critical for technical education is how do you manage and become profitable in the waste industry. We've already covered a lot of the economics of the landfill. We've noticed that frequently that leads to low-paying, low-skilled jobs for a lot of people because a lot of very valuable materials are just simply going to waste in the landfill. I might have mentioned a little bit that I had an intern this summer by the name of Nathan Hansen, who is working on actually a landfill mining technology, pretty high tech. My strategy is let's go ahead and sort those materials prior to them going into the landfill and keep the embodied energy, keep the materials themselves so they can be put to better use than creating a big stinking methane bomb. It's also filled with a lot of toxic materials. So that's why I saw recycling technologies as a valuable two-year skill to have. The OSHA training is critical because it's an industry-certified means of doing things properly, not just, hey, I'm going to go out in my backyard and yuck it up and figure it out, yeehaw. That's how people get hurt. That's how people get injured. And that's really why during the Carter administration, a lot of the renewable energy initiatives failed because a lot of the technologies that were put in place were not done so with oversight from national governing bodies. We also partnered with IREC, the Interstate Renewable Energy Council, as well as ANSI, the American National Standards Institute, so that when renewable energy technologies are put into practice, when recycling technologies are put into practice, they're done properly with oversight. Now, you may have heard that over the course of our TAC-3 grant, we did not have as high enough of an influx of students into the program to justify funding. That's one of the challenges of being in Montana. This $2 billion initiative goes out to the country. The fact that the state of Montana only has a million people in it and a few hundred potential students coming in. So unfortunately, for that reason, our funding was not continued. I'm still being paid by the state to teach this course, but as you recognize, recycling is still a challenge in Missoula, and we've gone through the economics of it, and that's really more or less why we're here, and it's also why we need to have the OSHA training. So I've scheduled that for another big thing with the Department of Labor grants. They wanted to see some kind of third-party certificate as a result, and so having OSHA as part of the recycling tech was a key component. Say, well, what do you really have to show for it besides the 3 credits? Well, I've got my OSHA 10 license, and I'm qualified to handle materials properly. Yes?
Does that have to be renewed?
Yeah, if I understand correctly, most of these OSHA certificates are renewed every 3 years. Because standards change, and they want to make sure that you're still engaged, involved, on board. So let's look at the calendar. So we've scheduled that for, I sent the email out. Yeah, the 21st and 22nd. I'm not here. I'm going to be in Washington, D.C. for my National Science Foundation grant. It's critical that I be there and reporting on what we're doing with my NSF grant. But and it's not critical that I be here. David DeFeer runs the course and has been doing it for years, and he's fantastic. So I will fill you in on the details of that, but it's a 10-hour course, and we've tried to schedule it in such a way that you've got 2 weeks notice, so that if you have to miss another class, you can get notes from one of your classmates. But it will be 10 hours total over the course of that Wednesday and Thursday, the 21st and 22nd. And I'll get you the exact details as soon as I have them from David DeFeer and as soon as Naomi has a room for us. So, does that answer the OSHA question you had there, Brian? Close enough?
Yeah, I was wondering the
Okay.
exact-
Yeah, we'll get you the exact times.
And then there's, after the 10 hours, there's a test?
Typically, there is a test or an exam. Yep. Yeah. But a lot of it is just making sure that as he goes through the material, you're awake, you're engaged, you understand what he's saying. It's not as rigorous as taking a full course. It's just that you've heard the information, you understand it, and I think there's a little bit of evaluation at the end. So yeah. Okay, so that good on the OSHA logistics, and sort of a little bit of background too, in like how this whole recycling technology course started in the first place. All right, so let's go back into the shell, and I just want to catch up on some old posts. I don't want to take a whole lot of time, and I know Joe Ryman-Schneider had a question on covering the exam. What's this, edible water bottle? Did you read this?
Yeah, I posted that.
Oh,
I watched the video, watched them do it. They take calcium with calcium alginate. I just did the basic. You Google it on YouTube, it comes up right there. Pretty real.
Where's your where's your post though?
You were just on there. Yeah, right there. You get cold calcium lactate and sodium alginate. It makes like a gel surrounding water, and then
Oh, I see. Okay, so
it's
it's
like this little. It almost looks like a mini breast implant.
so it's a non-plastic it's a non-plastic water container.
Yeah.
Okay, yeah, I've heard of sodium alginate. Neat.
Kind of a cool video. It's not
Yeah.
very long.
Okay,
I just happened to come across that and think, that sounds interesting.
yeah. Well,
Figured I'd throw it in under here.
is that what this is? I just don't
I
see.
didn't put any links.
No links. Okay. Well,
Like I said, if you just go to YouTube, you put in edible water bottle, it comes up pretty easy.
oh really? Okay, we can take a quick look. Okay. I mean, would you actually want to eat it? Does it give you any nutrition, or is this it?
It could be one of them.
This guy? Let's just hit that one.
When you run into your ex, Gillette Clinical activates the
Hey everybody, today I wanted to experiment and make these edible water bottles to see how efficient they are. Since there are 50 billion plastic water bottles used in 1 year and only a small portion of that is recycled, it becomes a huge pollution problem. Whether the plastic ends up in the ocean harming and even killing little fishies, or it ends up in landfills adding to global warming, it's not good. So we're going to begin by adding 1 cup of drinking water and 1 gram of sodium alginate. And then we're going to use a hand mixer and combine our ingredients. Then we're going to set that aside for 15 minutes to get rid of the bubbles. Then we're going to take 4 cups of water and 5 grams of calcium lactate, and we're going to stir that really well. And then using a measuring spoon, I'm going to carefully take the sodium alginate and plop it into calcium lactate. And it forms right away.
Is it forming a sphere? I'm not sure how it's.
You can continue doing this and make as many little edible water bottles as you want. And then we're going to stir for 3 minutes really carefully. And then we're going to take a spoon and again very carefully put it in another bowl of water just to stop the reaction. And that's it. I really enjoyed making these edible water bottles, but I do find that they're not very efficient. They burst very quickly, and when they burst, there is liquid inside. And you can go ahead and eat the outer portion. Thank you so much for watching. I love you, and I'll talk to you soon. Bye, guys.
Just one of those things that sound like, you know, if it could be better used, it's kind of.
Well, I guess that's pretty cool. I mean, I guess my take on it is that's like a interesting prototype or benchtop experiment, and if the chemistry were developed, you could probably turn it into something more durable. And I guess I've heard of similar things with edible packaging, where you're not using a plastic wrap that you have to throw away, but there's kind of a new edible or biodegradable packaging. So that's actually not a bad segue into today's lecture on cellulosic materials. But let's go back and see what other things in the forum I need to catch up on. So thanks for that post and response. Okay, landfill practices, I guess we've got a couple more on that. Waste to energy, new.
Yeah, there's no solution. Last week.
Shall use it flawless, but too often large industries don't realize they all have pollution control equipment. Still need to deal with the trash, filling the ground, oceans each day as we transition. That's some good writing there, Will. Skeptical about waste to energy being a single stream process, though. How effective is Covanta's metal pulverization separation process? Yeah, it's a good question. I do not know the answer to that. Lump together, ground up, and burn. Potentially continue. And I think I just had a really interesting conversation at the Montana DEQ last week, and the word burn is actually kind of a contentious issue because, you know, there's gasification, there's pyrolysis, there's incineration. I mean, almost in any one of these cases, you're dealing with oxygen combining with some carbon and energy is produced, but there's a lot of details on the temperatures and the reaction times and the how completely either, you know, the combustion or oxidation is a lot of details in there. So I'm skeptical too. I do think, though, there has to be some kind of carbon sequestration technology or set of technologies that suck it up faster than we're belching it out. So that just has to happen. And I'm working on several things. And I talk about that in a couple other links that I'll also show you during this lecture. Recycled to power their homes. Building material. Yeah, so right there, can the classic landfill mix be treated to convert as a building material? That goes right back to the whole philosophy that I've talked about before, is it's either going to be buried, built with, or burned. You know, all of this material is either going to go down, it's going to stay here and we're going to build with it, or it's going to, you know, for lack of a better word, be burned or turned into energy. So I think you're on the right track there with that, Will. Yeah, so I like it. And also, Will, thanks for sharing your Hazmat Days report. I'll take a quick look at that too. And this is a note to everybody in the class. Shelley a second ago mentioned, like, she's not available to go to every single field trip or a hands-on activity. And in this online course, it's impossible. I mean, that is the future of education. I mean, the education is becoming online, it's becoming more dispersed, and I can't expect you to be everywhere I am all the time. So I know that Brian and Jason have been working on their own with the Earth Tub. I've been working on my own. In fact, we're going to go back here and work on the bullpen a little bit and do some more hands-on triage. Andrew McChain is going to come in and actually grab the 2012 solar car and sort of, you know, move on to its next destination. So what I'm relying on everybody in the class to do is to just keep track of the hours you're doing outside of class, and by the end of the semester, You have to feel like, hey, I put in at least my 15 hours, and that's really the lab component. It's not that we're all in one particular lab doing the same exact thing. I'm sure you've gained from this class, I mean, there are multiple material waste streams that we're each dealing with. Pick your favorite, show me what you did, and that's your credit for your 15 hours. So, and I know, and you know, Shelley, you've been working on your electronics waste. I mean, that counts towards your 15 hours, no problem. And I guess since they're here, so Maria and Priscilla, what are you focusing on? What are your materials that you're focusing on, more or less? Yeah, because I mean, I really wanted each student in the class to focus on a specific material or artifact, really. There's somebody else that said they're going to grab all of the Tetra Paks. Brian and Jason are working on the earth tub. Shelley's working on electronic waste. And I know we talked about it previously, but could you just remind me what material you're focusing on and what your general project or goal is for that?
I was working with the plastics.
Plastics, yeah, okay, super. So let's just continue with that. And then Maria, did you have a particular?
Yes and no.
Okay.
Because that day I decided to work with electronic waste.
Okay.
But the TA told me to work with the bottle glass because we would work with it.
Okay. Is that okay with you? Do you mind working on the glass bottles? Is that?
I told him that essentially I don't know much about electronic waste, and I would be fine to work with the glass bottle, but like it's not my
Passion?
Yeah.
Okay. Well, and remind me your ultimate sort of career goal. I mean, are you both pursuing engineering degrees?
Mm-hmm.
Okay. Well, if you're looking for something, I have a pretty cool project that I could give you to do. That's relatively easy and whatnot. So remind me after class. It's a well, in fact, let me think here. I know I have it here on my computer somewhere, and I'll get back into that other topic. But more or less, we're talking about the each person's 15-hour project. Let me just think briefly where I put that. I think it's in courses 270 glass. Oh, here we go. Oh, and in fact, if you saw last week's YouTube, this is what you should watch. Just watch last week's YouTube. I actually delivered this from Billings. So, yeah. But I think this would be a great little glass project. I've got the tubing. We've got the bottles. I could put you on just a little 3D printing project to make this this part number 10 here at the bottom. For some reason, it looks like this. Oh, here it is. Yeah, 10 is the fitting. So let's talk more about that after class. Okay, super. Okay. And now let's get back to Will's post. Sorry, Will, to keep you hanging there. Issues, summarize hazardous waste day. I didn't know that you could exchange your mercury thermometers. That's kind of nice. Latex paint. I think latex paint would be another good candidate for waste to energy. I mean, it's a hydrocarbon. It's just something that I think would be a good waste to energy candidate. Oh, yeah, yeah. Has
Which
waste.
part was that actually falling in over the source?
Yeah, that's a big one, too. By purchasing or disposing of flammable liquids, oil, paints, and the like, we're supporting the practices of the industries that make or dispose of them. I run into the same problem all the time. Like 2 years ago, I went to refinish my deck railing, right? So it's Montana, it gets really hot, it gets really cold, freeze, thaw, all this. And so it's tough on the wood. I had latex paint, or somebody had painted latex paint on my deck, and it was just peeling off. It needed constant attention. So I sanded all that off. I put on a layer of boiled linseed oil. I don't know if you heard of that, but natural bio product. It sort of became fungal, though. I got like a black mold growing on there and really just kind of made the thing look nasty. So I bit the bullet. I put some oil-based stain on it, and it really made the wood look a lot better. I then put some polyurethane sealant on it, and it will preserve that wood better. And again, polyurethane, yeah, that's a petrochemical, so there's no one solution, I guess is what I'm getting to. I wish there was. I mean, I wish the boiled linseed oil would have worked, but it requires attention too and maintenance.
To have that new, like number 2 plastic lumber,
Oh, the HDP lumber, sure, yeah.
I don't know how long it lasts.
I think that was extraordinarily, I mean, the HDP lumber would be way more durable than wood, absolutely. In fact, I was also doing my deck over the weekend and realized that some of my cellulosic material, which we're going to cover today, which is wood, was turning back into earth. I mean, there was rot there, and so in some ways, that's maybe not a bad thing either. If our wooden structures just sort of rot away and go and move from that, move from that build category into the bury category, and in a non-toxic way. Okay, dispose of them. Toxic, some incinerators, power furnaces, yeah. Yeah, it's tough. I mean, there's always a not in my backyard issue with all this stuff. And part of the book that I'm writing, I was really trying to take a yes in my backyard approach. And sometimes to the detriment of my own property value. And I think I've done a pretty good job keeping my yard neat. I mean, I've got a compost pile, a lot of things go in there. I've not had any animal problems. I've used a lot of reclaimed materials, but it can frequently look unconventional. And so again, we're talking about a not in my backyard issue here versus a yes in my backyard. And I like this one too. Martin No Runner and I of IE Recycling have been working really hard to get a zero waste curbside business going. We sent the letters out, and unfortunately we did not get any responses from any of my neighbors, and we figured that it was more than likely one of 3 reasons. Either one, they didn't, they thought it was just sort of junk mail and didn't see it and just threw it away to start with. 2, it was too expensive. His starting price was $150 per quarter, $600 a year for for zero waste curbside, versus Republic, which is sitting right around $300 a year. So that's tough, and it's the same exact issue we talked about previously of whether or not to have the recycling facility at the university at all, because it just sort of costs extra money on top of what the landfill would have charged to begin with, without having it at all. Or 3, it's just too complicated. Most people do not want to do multi-stream waste. So there's all kinds of sort of reasons that this thing is not taking shape in the way most of us would hope. People would bought materials to has. serious thought, the consequences, I agree. Redefine, why do we need to drive our cars across town when we can bike or bus, killing weeds, agree. Ecological justice. This sounds like an environmental student's point of view. I've heard this a lot. And really, also, just to kind of get everyone back on the same page in terms of what the role of the energy technology program is, it sits sort of as one leg of a little tripod. And it seems like where Will's coming from on this essay is sort of the problems leg. We're gonna point out a problem. The next leg is sort of the policy leg, and within the climate change studies program, it's like, how do we enact a policy? And I think Will is addressing that. And then the third leg is the practices. So problems, policy, and practices. And practices is where the energy technology program comes into place. Or solutions. What is the appropriate technology for moving forward to deal with these problems? Okay. Ecological justice, there's your policy. Yeah. Okay. Well, that was a great post, and thank you very much. I'm glad you all are stepping up to the plate on the forum. That's fantastic. All right. With that, education concerns. I'm going to pause the recording, and then I just want to say a few things about cellulose for today's lecture, and then we'll do some hands-on. Oh, I'm sorry, and there's one more question on embodied energy that I'll get to with Joe. I'll do that in the next little segment here.